Really, chemical warfare has been sporadic throughout history, and you'll find that it was used in ancient China in 500–600 BC. Alexander the Great's soldiers were dipping their arrows into snake venom, all sorts of random events. But it's really not until maybe the last 100 years that chemistry was really applied in a scientific fashion to develop weapons. These are really heinous compounds. They come in different classes, but at the end of the day, they cause real syndromes that aren't typically experienced in your normal medical scenario. So making sure that we are developing drugs that are available for doctors to administer in a situation that someone were to be exposed, or worst case scenario, in a mass casualty situation where thousands or tens of thousands of people are exposed.
A special talent of MRIGlobal is the ability to bring multidisciplinary teams together to collaborate to solve a problem. In applied research, most often you need to have many disciplines working together. And I think we're especially good at this, and it fit the complex problem of treaty verification and stockpile monitoring and all of that. So it fits well with our culture and what we do well. A lot of the work in the early days was engineering and even economic. And when I came, my background was analytical chemistry, and I was very glad and lucky to be able to join that team with some ongoing work, especially in treaty verification, because without good verification techniques, there really can be no effective treaties. The advances in analytical chemistry really made it a tool that could be used to impact national policy. And so I happened to come along at the right time. Chemical engineers, of course, were familiar with processes and how manufacturing plants produce chemicals. And so the engineers were looking for which processes were being used, what related compounds might be there, to guide the chemist on what to look for. Economists were looking at the movement across countries of things like phosphorus, because it was a key component of some of the most toxic agents. And so, of course, these are pretty, I would say, non-specific compared to analytical chemistry, where you're detecting molecules. But at that time, until analytical chemistry grew up, then those were the initial things that were being looked at. I was able to participate in a few of those, and those were meetings of international experts in a variety of areas, but in chemistry was one. And it was a meeting of really technical people to be able to come to some agreements on what one could put in a treaty, so both sides could be confident that the treaty would work. And so part of the work that we did at MRIGlobal was to create databases, to create analytical methods, and to build pictures of what a site would look like in the surrounding environment. Over the years, a lot of the methodology, analytical methodology and others, were things that led to the final methodology that ended up in the treaty. And MRIGlobal did work in really furthering the technology of treaty verification. Really beginning in the 80s with a lot of, not just in Pugwash, but a lot of other meetings among collaborators and collaborating governments and experts to actually start to put together a protocol that was eventually accepted in the Chemical Weapons Convention, finally signed in 1993.
Today, what we're doing here in these mobile laboratories is to deploy our know-how and our technology to support the non-proliferation of chemical and biological and explosive technologies. How we've done that over the years is we've started with doing basic science, understanding the chemistry, the stability, the byproducts of the chemical weapons, of the biological weapons, but then moving on to, well, how do you collect them? How do you detect them? How do you mitigate them in the end? So what do you do to decontaminate them? And We've brought all of that together in these mobile laboratories where now we can take all that technology that we used to do in our labs and we can take it to the field where it can be done quickly and exactly where the decision makers need to use it. In these mobile laboratories, we have chemistry, we have biology, we have engineering capabilities that we've deployed, assembled, organized to be able to take our expertise to the field to be able to do these kinds of experiments. We've done a number of programs that I would consider to be more in the human health arena. For example, providing support for medical countermeasures which are used to either proactively mitigate what would happen if you get exposed to a weapon, as well as treat you if you did get exposed to a weapon. And so we're conducting work along those lines to help support those techniques. In addition, we've done some engineering programs where we've integrated a variety of folks together to build capabilities to test chemical protective suits, for example. So one of our programs was the Individual Protection Ensemble Mannequin System, which is now deployed at Dugway Proving Ground. And that can be used for testing chemical suits in a very realistic environment in a very highly toxic scenario. Our mission is to use science and technology to create solutions for a safer, healthier, more sustainable world.
It's certainly well-deserved. I mean, for Bob, this has been his life's work, and to see it culminated in a treaty, and even though he has to do a lot of hard work now trying to enforce it, but it's got to be tremendously satisfying, and it's well-deserved honor for him.